All right. Hello, everyone. My name is Rachael Keneipp, and I'm a PhD student in the physics department here at Penn. And today I want to talk to you about blue energy and how water could be a clean and renewable solution to the energy needs facing our world today. Come on. So if you look around the world today, what you'll see is, especially in developing nations, there's an increase in demand for energy. Over the next 25 years, it's predicted that we'll need about 11% more energy than we need today. What that translates to is about 100 exajoules of energy, or the amount of energy the United States consumed alone in 2024. So if we look forward by 2050, as a world, we're going to need enough energy to power another United States, and that's a lot of energy. Unfortunately, most of the energy that we consume as a world is still fossil fuels. Fossil fuels, when burned, release greenhouse gases and carbon dioxide into the atmosphere, warming our planet. And this warming can have terrible effects on our environment. And we see these effects all over the world. From the hurricanes that ravaged the East Coast that have devastated communities like North Carolina, to the wildfires in California that seem to never stop. And these types of effects can be seen right here in our own city. If you've been living in Philly for a while, you've probably noticed some of these effects over the last couple of years. In 2021, hurricanes that blew through the East Coast caused the Schuylkill to flood so high, people were jumping off the overpasses into the floodwaters. And in 2023, the Canadian wildfires changed the Philly skyline into an ominous and hazy orange. Now, if we want to reverse course, and really reclaim our environment, what we need to do is we need to reduce our reliance on fossil fuels. And there are a couple of ways to do this, but really the best answer we have is to move towards renewable energy. Now, you've probably heard of a lot of different types of renewable energy, everything from solar energy to wind to hydroelectric. These power sources that typically fall under this category of green energy are seemingly inexhaustible, but a lot of them actually have really bad effects on the environment or rely on certain environmental conditions to be met to be generated. Solar energy isn't generated if the sun isn't shining. Wind farms can have a devastating effect on birds, and dams, where they're built, completely alter the ecosystem. But today, I want to introduce you to a new type of energy, one that doesn't rely on the sun shining or the wind blowing, and it's available 24/7 with a minimal impact on the environment. And that energy is blue energy. Blue energy is an energy that's derived from the mixing of salt water and fresh water, and I'm going to explain exactly how that works. But the key to blue energy is a unique technology we're developing here at Penn called an osmotic membrane. I want you to think of an osmotic membrane as a special filter. And just like any filter, it keeps some particles in while letting other particles through. And in fact, you may have used something like an osmotic membrane this morning if you made a cup of tea. When you make a cup of tea, you put leaves in a bag and you put that bag in water. And what happens is this bag, your tea bag, acts just like an osmotic filter does. Now, when you make a cup of tea, there's another very important physical concept at play. And this physical concept is the concept of diffusion. And it's also very important for blue energy. Diffusion is this idea that if you have a lot of particles bunched up in one place, they don't want to stay there. Rather, if they have the space, they're going to spread out. So when you make a cup of tea, you have a lot of tea particles in a bag, but they don't stay there. They move through that filter and they diffuse across the membrane. When we make blue energy, we rely on these same physical principles. To make blue energy, we essentially design special osmotic membranes, special filters that filter out positive salt particles from seawater. And I want to talk about how this works up close. So to make blue energy, what we need is salt water and fresh water. We start with these two fluid reservoirs. And what you'll notice is on the saltwater side, we have two different types of particles. Our angry green negative particles and our happy pink positive particles. And if you remember that process of diffusion, this idea that particles don't like to be bunched up together, what will happen over time is these particles want to spread out. However, what we have here is our specially designed osmotic membrane. And what will happen is over time, these particles will spread out, but only the positive ones are going to make it to the freshwater side. So what we have here is positive charge on one side and negative charge on the other. We have a buildup of charge. And what this might remind you of is a battery. And just like a battery, if we put a circuit across this battery, across this membrane, energy will flow. And this, folks, this is blue energy. So from just salt water, fresh water, and a specially designed membrane, we have been able to generate electricity. Now, you might be wondering, if it's that easy, why have we not done it yet? Like, what is the holdup here? The question we have is, how do we make these osmotic membranes for blue energy? And really, this is the question that is the key to my research. Here at Penn in the physics department, I study how we can make membranes for blue energy. And in our group, the Grad group, Our answer to this is a unique class of materials called two-dimensional materials. 2D materials are materials so called because they are just one atom thick. They are a millionth the thickness of a piece of paper, and yet they are stronger than steel. And what's so exciting about these materials is that we are able to design them to have holes that are just a few atoms wide. And what I do as a physicist is I study the physics of these very small holes that we affectionately call nanopores. And by understanding the physics of these small holes in these very thin materials, we can understand how we can get salt particles that are positive to move through while blocking out the negative ones, allowing us to generate blue energy. Now, the work we do in the Drindich group is on a very small scale. However, work by other physicists like me have shown that if we're able to scale up this technology in the right conditions, 1 square meter of our membrane technology could be enough to power 2,500 US households, and that's a lot of energy. And really, everything we need to generate this energy already exists. Estuaries, where saltwater and freshwater meet, provide the perfect places to build blue power plants. And in the Netherlands, there are already some companies building blue power plants. And although their osmotic membranes are not as efficient as the ones we predict, it still shows proof of principle that we can build these kinds of plants and they can make energy. And really, the need for renewable energy is more urgent than ever. Every second we continue to burn fossil fuels is another second our environment continues to warm. And really, we need to retake our environment, not only for our world, but for our city. And really, I'm very hopeful that the technology we're developing here at Penn will lead to a day that, rather than the Schuylkill flooding or the sky being hazy, we might actually see a day where it's always sunny in Philadelphia. And the skies are blue, because the energy is too. Thank you.